All right, guys, today we're starting something brand new. Gonna look at some matrices. Today we're just doing the basic things, performing just the basic matrix operations. So pay close attention because it's new, but I will tell you this, it's not very difficult. So just hang in there. Few words to start with. Of course, a matrix. All a matrix is a rectangular arrangement of numbers and rows and columns. I got a picture of one down here. That's what they look like. Every matrix has dimensions, which we do rows first, columns second. So we call them n by n or rows by columns. You read it m by n. The one down here, if you go how many rows it has, the rows go across, the columns go up and down. So that one will be a 2 by 3 matrix, a 2 by 3. Elements are the numbers inside a matrix. So that 5 right there, that's an element. The 6, that's an element. Matter of fact, the 6 you would say is in row 2, column 2. This 3 right here would be row 2, column 3. But it's a 2 by 3. That's how you read it. A rectangular arrangement. Elements are the numbers inside. Adding and subtracting, this is mainly what we're going to do today. Very easy to do. All you do is to add two matrices is you add their corresponding parts. The A and the E are the first elements in the matrices. They get added together. The B and the F are next. They get added together. The C and the G hold the same place. They get added together. The D and the H get added together. Subtraction works the exact same way. You just subtract instead of add. So one key that I didn't read up here though is that you do need to know, you can only add or subtract only if they have the same dimensions. If they're different sizes, you can't do it. Both of these, if you look at them, that's a 2 by 2, this one's a 2 by 2, therefore it's legal. If they were different sizes, one was a 3 by 2, one's a 2 by 2, don't try it because some of you will come up with a way to do it, but you can't legally do that. They have to have the exact same dimensions. All right, let's look at a couple examples here. This first one's addition, and just like we just saw, I'm going to add the corresponding parts to 3 and the negative 1. That's going to give me a negative 3. Let me go back to the back. Negative 3. Now the 0 and the 4, that gives me a 4. Negative 5 and 2 is negative 3, and then negative 1 and 0 is negative 1. That's all there is to it. Now, I do need to make sure, though, and I didn't do this at the beginning, that's a 2 by 2, that's a 2 by 2. That's the only reason I can do that. Now, if I'm looking at these, this one's a 3 by 2. This one's a 3 by 2. So again, I'm legal, I can go. So I'm about to do this. Make a new matrix over here, and I'm subtracting, straight across. The first row, first column by first row, first column. 7 minus negative 2, same thing as 7 plus 2, which is 9. Now I'm doing the 4 and the 5. 4 minus 5 is negative 1. Let's go to the second row. 0 minus 3. Negative 2 minus negative 10. Same thing as negative 2 plus 10, which is 8. Negative 1 minus negative 3. I'm on the bottom row now. That's 2. And then 6 minus 1, that's 5. So all there is to it, you add or subtract their corresponding parts and make sure they have the same dimensions before you start it. One thing we haven't seen yet, there's a 4 on the outside of this one. That 4 is called a scalar. That's the official name of it. Before you add or subtract, you need to take care of that scalar. What you do with a scalar is you distribute it inside the matrix. So I'm going to multiply every number in there by 4, like that. And once I do that, now I'm ready to add the two matrices together. And I'm allowed to, again, because they are both 2 by 2. So I'm just going to add straight across, negative 8 and negative 3, negative 32 and 8, 20 and 6, and 0 and negative 5. So the only new thing there was the scalar on the outside, and you need to take care of that first before you start your addition. All right, our matrices do have some properties associated with them. And you've heard of every one of these before. The associative property of addition still works. You can group two. If you have 3 matrices you're adding together, you can group whichever 2 you would like to first. Commutative works. If when you add matrices, it doesn't matter which order you add them in, you'll get the same result. Distributive with a scalar in the front is k. You can distribute that across the matrices. Same thing with subtraction, addition or subtraction with distributive. So those are the main properties that work with matrix operations. Okay, let's try one with everything. This one says, this is the last slide, by the way. It says solve the matrix equation for x and y. So we got to solve, sorry about that. I'm going to follow the order of operations here. If you notice there's a 3, which is our scalar out here in the front, but it's outside of big parentheses. So what I'm going to do first, I'm going to leave the 3 alone, And I'm going to take care of what's inside that parentheses, which is two matrices added together. So I would add the 5x and the 3, which is 5x plus 3. I'm going to add the -2 and the 7, which is 5. 6 and -5 is 1. And -4 plus -y is -4 minus y. And that equals this matrix over here. Now, I'll tell you this, we haven't talked about this yet, but the only way two matrices can be equal to each other is if every single element is the same in both matrices. So what I'm going to do now is I'm going to distribute that 3, the scalar. That's going to give me 15x plus 9 when I do that first term right there. 3 times 5 is 15, which I really needed to get the 15. 3 times 1 is 3. I needed that too. And then do 3 times the -4 and the y. And I get that. Now, the reason I said I needed the 15 and I really needed the 3 is because if you look over here on the right side of the equal sign, look at the places. I got the 15 because that's 15. I got the 3 because that's 3. If two matrices are equal, every single element must be equal. So what I'm going to do is I'm going to take this 15x plus 9 and set it equal to that. They have to be equal to each other. So I'm going to say, okay, 15x plus 9 has to equal -21. So I'm going to move the 9 to the other side. That's going to be -30 divided by 15. There's my x, which is what one of my jobs was. It says to solve for x and y. There's my x. Now my y's, that has to correspond that those two have to be equal because they share the same spot in the two matrices that are equal. So I'm going to set -12 minus 3y equals -24. Have to be equal. So I'm taking the 12 over. When I do that, that side becomes -12. Divide by -3, and you get 4. So there's your x, there's your y. All there is to it. That's probably the most work you'll do on one all day today. So matrix operations are not that hard. I will say this, tomorrow we'll probably work on matrix multiplication, which is a little bit more complicated. Addition, subtraction, definitely the easiest things to do, but you need to know those terms too. Make sure you know what an element is, what the dimensions are. The dimensions are going to be extremely important as we go on, so make sure you can do dimensions. That's all we got today. See you in class tomorrow. See you, bye.